The hardware consists of a 2.3 HP 4-pole 5200 RPM PMBLDC motor having a rated current of 4.3 amps and a rated torque of 3.2 Newton meter, and it is coupled to a DC motor. The motor is supplied through a 25 kVA 6-switch 3-phase semicron inverter whose DC supply is fed via a rectifier, which in turn is connected to an auto transformer. The gate pulses of the semicron inverter is supplied at 15 volt level via this isolation and amplifying circuit. The isolation and amplifying circuit consists of an isolating part which has 6N136 optocoupler and an amplifying part which has TPN222A NPN transistor. The input to the isolation and amplifying circuit is at 3.3 voltage level, which is provided by the Texas Instrument processor TMS320F2812. The processor takes in 3 Hall effect signals as input and processes them to give 6 gate pulses or output. This is the field supply to the DC motor, which is coupled to the PMBLDC motor, and the motor is loaded by loading the armature of the coupled DC motor with a 230 volt single phase 24 ampere variable resistive load.
Now that we have dumped the code on the processor and configured the input and the output pins, we would now like to run the motor by increasing the voltage at the auto transformer. You can see the motor has started running. Now we would like to run it at 1000 RPM. You can see the motor has started running at 1000 RPM. Now we would like to apply the load and see what it happens. We have switched on the field supply. Now we will apply load at the armature of the DC coupling motor. You can see the speed has reduced. Now we would like to increase the voltage to 1000 RPM again by increasing the voltage. You can see we have again reached 1000 level RPM. Now we will again reduce the load which we have applied. You can see the speed has again increased. The speed has again increased to 1100 RPM.